Okay, let's talk about real zeros, specifically the number of real zeros. We'll kind of also get into the number of zeros and how we can tell if they're real and all that good stuff. Yeah, so first, let's do a little bit of notes here. So, a polynomial is simply just what you can think of as an equation where the x's go from highest power to lowest power, and the powers are all integers. Okay, and I put this little note that x to the 0 equals 1, and I'll show you why. So, it's something like this, where I have a number times x to its largest power, and then plus another number times x to just a power smaller than this. And we go all the way down till we get to a constant number, right? And here's where this was x to the first, and then x to the 0, right? So that's why it's a times just a 1 here, right? And this is just the same thing as something like this, right? It'd be 2 times x to the fourth, and then minus 5 times x to the third, plus 3 times x squared, minus 2 times x to the first, and then just a constant. All right, so all the powers are integers. That's a polynomial. Okay, and we're going to use a lot of polynomials for this particular video. Okay, also note that every polynomial can be written, every polynomial with a degree n can be written as a product of n factors. So if this is my polynomial, I can actually factor this to some constant times n factors. All right, so just like you factor quadratics, a quadratic has a power of 2, and there are 2 factors. This has a power of n, so there are n factors, all right, which means that every polynomial of degree n has n solutions. Okay, so there are n solutions. Now, I'm not saying they're all real solutions, all right? I'm not saying that some can't be doubled, but can't be multiples, but there are n solutions always, all right? Okay, so let's take that. Let's do a couple of problems here. Well, a few. So I know how many solutions does each of these equations have, and they're all polynomials because they all have powers that are integers. Then you'll look, the first one's a quadratic. It has a power of 2, so that means there are 2 solutions, right? Again, I'm not sure if they're real, if they're complex, or if they're maybe doubled, but there are 2. Okay, this one has a power of 3, so there are 3 solutions. Okay, this one has a power of 5. So on this one, I was kind of tricky, and I put the power kind of in the middle somewhere, but it's always the largest power. All right, so whatever the highest power is, that's how many solutions there are. So this one actually has 5 solutions. And in fact, since it's equal to 0, it has 5 zeros. The solutions are zeros. Okay? All right, so let's stop this and complete classwork problem 1C. Okay, so now do the same thing. Let's talk about or state the number of zeros, right? And then we're going to graph to find the real zeros. Well, the first part is this is just an expression. How do I find the zeros? Well, I set it equal to 0. So now I have an equation where I can find the zeros. All right, so how many zeros are there? Well, it's a power of 3, so there are 3 zeros. Well, let's graph now and find the real zeros. So remember, a 0 is where the graph crosses the x-axis. It's when y is 0. And you can see there's only 1. It only crosses the x-axis once. So there is only one real 0. Okay, and there are 2 other zeros that aren't real numbers, right? And those are complex numbers, and we'll get into those later. Right, but that's the deal. A 0 is when y equals 0. So when y equals 0, it's the x-axis. It's only across the x-axis one time, so only one x-intercept, one real 0. Right, and so out of the 3 zeros, only one is real. All right, so you want to complete classwork problems 2B and 2E. All right, let's do the same thing. Let's say the number of zeros, and then let's solve for the real zeros. All right, so here I have a nice linear function. So x has a power of 1, right? So we don't write the powers, it's a 1, so there is one solution. And in fact, I should have written, right? It's not just a solution, it's a 0. There is 1, 0. Well, let's solve. So this is just linear. So I'll subtract 1 from both sides. I'll divide by -3, and then a negative divided by negative is a positive. So x equals 1/3 is a real number, right? So if I put in 1/3 into that equation, I will get a 0 as an output, which means since it's a real number, that's the real 0, right? So x equals 1/3 is the real 0. So I knew there was 1, 0, and that's it. Okay, let's do a little notes here before we go to the next problem. So the quadratic formula, I'm sure in algebra you learned this, but if you're given a quadratic, right? So some constant times x squared plus some constant times x plus another constant. If that equals 0, you can use the quadratic formula, which is simply just change the sign of b, plus or minus b squared minus 4 times ac. Again, the a, b, and the c I'll get for the numbers that are the coefficients and the constant, and then divided by 2a. All right, so if we use this formula, we can actually solve this equation for both of its solutions. Right? And when I said both, right, it's a 2, has a power of 2. There are 2 solutions. And this equation will always give me both solutions. All right, so they might not be real, but it'll give me 2 solutions. All right, okay. So let's do this. Let's state the number of real zeros, then we'll solve for the real zeros. All right, and we'll do this algebraically. I didn't really put that, but not graphically, algebraically. Well, you can see I have an x minus 3 times an x squared, blah, blah, blah. So really, I just take the highest powers. This is really an x cubed. All right, so if I were to do the distribution, the largest power would be an x cubed. So I know that there are 3 zeros because the largest power is x cubed. All right. Well, zero product property law, right? I can take this. If this is 0, then the whole thing is 0. If this is 0, then the whole thing is 0. So what I can do is separate those into 2 equations. And I'll start with the x minus 3. All right, so I'll set that equal to 0. Then I'll figure out what makes that 0. So add 3 to both sides. So x equals 3 is a 0 to this equation. All right, so plug it in. I'll get 3 minus 3 is 0. Then a 9 minus 12 plus 7. Who cares even what that is, because 0 times that will be 0. So this is a 0. Okay? All right, see if we can find our other zeros. So now I'll take the second product and set it equal to 0, right? Because either one of these could be 0 and the whole thing is 0. So I'll do x squared minus 4x plus 7 equals 0. We're going to try to factor. So I want factors of 7 that add to negative 4, right? Never going to happen. Factors of 7 are 1 and 7. Either I'm going to get a positive 8, or if it's negative 1, negative 7, I'll get a negative 8. That's never going to work. All right, so I cannot factor this, which is why we did the quadratic formula. Okay, so I can put it into the quadratic formula, where a is 1, b is negative 4, and c is 7. So if I put it into the quadratic formula, I'll get a change in b, so negative 4 times a negative is a positive 4. And then I'll square b minus 4ac all over 2a, do the simplification inside, and you'll see I'll come up with a 4 plus or minus square root of negative 12. All right, so right now I just need you to make a note that if you come up with a negative radical, that means it's not a real solution. Okay, so this doesn't yield any real solutions because there's a negative under the radical. Okay, and I'll explain why that is a little bit in just a second. So it means that x equals 3 is the only real 0. All right, okay, so when you're solving quadratics, if you can't come out with a real number, it means it produced 2 solutions that aren't real. All right, so in this case, we have 3 total zeros, and only one of them is real. So if I were to graph this, so if you were to graph this in decimals or on a calculator, anything you want, I would only get one x-intercept. All right, that's what that means. Okay. All right, so now let's talk a little bit about the square roots and why a negative under the radical is not a real number. So think about this. If I have x squared equals 9, I square root both sides, I get x equals plus or minus 3. So the idea here is this. I need a number that I can square that will be a positive 9. Well, piece of cake, right? 3 squared is 9. Negative 3 squared is 9. So there's a real number that when I square it, I get a positive 9. Well, what if I had x squared equals negative 9? So now I'm asking what number, when I square it, gives me a negative? Well, we learned that when you square a number, it's always positive. So there isn't a real number that I can square to get a negative number, right? There just aren't any real numbers that do that. So you'll see if I square root both sides, oh, there should be a plus or minus here. But the key here is the radical and the negative. So this idea that I'm not going to be able to square a real number to get a negative is the exact same thing as taking the square root of a negative. It means that I'm looking for a number that when I square it will be negative, which just isn't true for real numbers, right? It'll never happen. Okay? All right. That's why you look out for negative radicals or negatives under the radical. Okay, so that's actually the end of the video, but you want to complete classwork problems for A, for C, and for D.